to Dr. Shahrizan. I present the mind map of all the synthesis and reaction in the course of SKO3023 with my partner. First of all, I want to introduce myself and my partner. My name is Manjahal and my metric number is D2021109939.
My name is Siti Dalina binti Damansya and my metric number is D202110993330.
From the screen, we can see that all the synthesis and reaction of hydrocarbon. Therefore, I will start with the most simplest of hydrocarbon, which is alkane. Firstly, there are several processes which can synthesis alkane. Alkane can synthesis by hydrogenation, which also known as addition of hydrocarbon from alkenes. In this process, alkane will produce by an alkene with the presence of catalyst, which is nickel, tungsten or platinum and hydrogen gas with a high temperature which is 150 degrees Celsius. Next, I will explain about how reduction of alkyl halide to produce alkane. There are two processes in this reaction which are hydrolysis of gradient reagent and reduction by metals or acid. Now, I would like to talk about the reaction of alkane. Reaction of alkane included halogenation, free radical mechanism, and combustion. Now, I would like to continue the presentation with reaction of alkenes. First reaction of alkene is addition of hydrogen to produce alkane, which is same with the synthesis of alkane. Next, addition of halogen will turn alkene into dihalide alkane, and this reaction can test for unsaturation of bromine gas. Furthermore, addition of hydrogen halide in alkene will produce alkyl halide. Besides that, addition of sulfuric acid from alkene will produce alkyl hydrogen sulfide. Next, alkene react with water will produce alcohol, and if the alkene react with water and halogen, it will produce halohydrine. Oxymercuration, demercuration, also one of the reaction of alkenes. This reaction produce alcohol and include H2O, Hg(O), ASC(2), which is mercury 2 acetate, and NaBH4. Hydroboration, oxidation of alkene will produce alcohol, but this reaction will involve anti-Markovnikov orientation. This reaction need diborate, hydrogen peroxide, and sodium hydroxide. Free radical will change alkene to alkyl halide, and this reaction also involve anti-Markovnikov rules. Next reaction of alkene is epoxidation, and this reaction produce epoxide by include pre-oxybenzoic acid. Hydroxylation is involve KMNO4 or pre-oxyformic acid to produce diol. Allylic halogenation is the reaction which convert alkene to allylic halide. It includes Br2 and high temperature 350 degrees Celsius, or just use catalyst and bromosuccinimide. Ozonalysis of alkene will produce carbonyl with presence of ozone, zinc, and water. Last but not least, alkene can also undergo vigorous oxidation. Now, I would like to continue the presentation by explain all the reaction of alkyne. First of all, catalytic hydrogenation is undergoes by convert alkyne to alkane and present with hydrogen gas and platinum, tungsten, or nickel. Catalytic hydrogenation can also involve to produce cis alkene, but different catalysts which are hydrogen gas, barium sulfide, and Lindard catalyst. Furthermore, metal ammonia reduction of alkyne to produce transalkene. Addition of halogen will produce a tetrahaloalkyne. Addition of hydrogen halide can also involve in the reaction of alkyne, and the product of this reaction is dihaloalkane. Hydration of alkyne will produce ketone, and it includes of HgSO4 or H2SO4 and water. Oxidation of alkyne involved in two types of condition, which is KMNO4 with room temperature and heated KMNO4. Last reaction for alkyne is ozonolysis to produce carboxylic acid. Lastly, I will explain about the synthesis of ether, and the only reaction for ether is Williamson ether synthesis. This synthesis is alcohol react with alkyl halide or tosylate to produce ether. That's all from me, and I would like to pass the presentation to my teammate Dalina, and thank you.
Next, I will present about synthesis and reactions of alkyl halide. The first one is free radical halogenations from alkene. Chlorination produces a mixture of product with presence of UV ray at 125 degrees Celsius. Next, free radical allylic halogenations. Halogen is placed on a carbon directly attached to the double bond with presence of UV ray and bromosuccinimide. For the substitution reaction, the halogen atom on the alkyl halide is replaced with a nucleophile. Elimination reactions produce double bond. The alkyl halide lose a hydrogen and the halide, also called dihydrohalogenations. For the SN2 mechanism, biomolecular nucleophilic substitutions, concerted reactions, a new bond form and all bond breaking at the same time. Red is first order in each reactant. SN2 reaction will result in an inversion of configurations called a Walden inversions. The SN2 reaction is a one-step reaction. Next, the SN1 reaction is the unimolecular nucleophilic substitution. It is a two-step reaction with a carbon cation intermediate. Red is first order in the alkyl halide, zero order in the nucleophile. Racemizations occur. The E1 reaction is a unimolecular elimination. Two group loss, which is a hydrogen and the halide. Nucleophile acts as a base. The E1 and SN1 reaction have the same condition, so a mixture of product will be obtained. The E2 reaction is a biomolecular elimination. Require a strong base. This is a concerted reaction. The proton is abstracted, the double bond form, and the leaving group leave all in one step. For the synthesis of alcohol, alcohol can be synthesized by nucleophilic substitutions of alkyl halide. Hydrations of alkene also produce alcohol, oxymercuration, demercurations, and hydroborations oxidations. Reactions of a grenite with formaldehyde will produce a primary alcohol. Additions of a grenite reagent to an aldehyde will produce a secondary alcohol. Tertiary alcohol can be easily obtained by additions of quinine to a ketone with dilute acid. Next, quinine reaction with acid chloride and ester use 2 mol of quinine reagent. The product is a tertiary alcohol with 2 identical alkyl group. Reaction with a 1 mol of quinine reagent produce a ketone intermediate, which react with the second mol of quinine reagent. Reactions of quinine with carboxylic acid derivative will produce a tertiary alcohol, and reductions of aldehyde will yield primary alcohol, and reductions of ketone will yield secondary alcohol with presence of sodium borohydride or lithium aluminium hydride. Reduction with lithium aluminium hydride from ester to primary alcohol. Next, for the reactions oxidation of alcohol, oxidation of primary use alcohol to form aldehyde, and oxidation of primary alcohol using potassium permanganate or potassium dichromate to form carboxylic acid. Oxidations of secondary alcohol using potassium permanganate or potassium dichromate to form ketones. Okay, that's all from us. Thank you.